So we're on topic 14. We're going to break page 68 down into three main parts. We're going to look at the definition. The topic, of course, is solving quadratic equations by factoring. So we're going to see how the definition plays into that. So we need the definition of a quadratic equation. We're going to look at the zero factor property. And finally, we're going to give an example solution for a solution of a quadratic equation. So first of all, what's the definition? Well, the definition is an equation in one variable x that can be written in the standard form as. So this is a quadratic equation. There's one variable x, there's an x squared term, there's an x to the power 1 plus c, which is some number, usually some number equals 0. So this is the standard form of a quadratic equation. There is only one variable. Now there is a proviso that a, b, and c, this means elements of, we discussed that in topic, or belongs to the real number set. So these numbers must lie on a real number line, and a cannot equal 0. So a, b, and c must belong on the real number line, and a cannot be 0, written like this. See topic 1 to review that. We use the quadratic equation to find the values of x that make the equation equal to 0. We take this equation here. For reasons that we will explain very shortly, the value of x minus 1 will make the equation true. Let's see if that's true. So we write down the left side of the equation, x squared plus 2x plus 1, which is this side here. We substitute minus 1 for x, minus 1 squared, plus 2 times minus 1, because x is minus 1, plus 1. And so this becomes 1, minus 1 squared is 1, 2 times minus 1 is minus 2, and we've got the plus 1. So when you sum 1, minus 2, and plus 1, it sums to 0, and the right side of the inequality is 0. Now, to solve a quadratic equation, we have to make use of the zero factor property. What does the zero factor property means? That if we have the product of a and b equals 0, the product of two numbers or two terms is 0, then either a is 0 or b equals 0. So, for example, we say xy equals 0, then either the first term equals 0 or the second term equals 0. If, for example, x times x minus 6 equals 0, the first term, one of the possibilities that x equals 0, or the second term equals 0. So, either when we bring the minus 6 to the other side, we get x equals 6. So if we plug back into this equation either 0 or 6, we will get this. Let's say we put 0 here. That's one of the solutions. 0 times 0 minus 6. 0 times minus 6 is 0. The other solution is I could try 6. So put a 6 here, and 6 minus 6 is 0. So 6 times 0 is equal to 0. When we solve this, either we assume the first term was 0, or we assume the second term was 0. So that's the zero factor property. Don't worry, we're going to see many instances of how to use this. So the procedure is first we factor the standard form completely, then use the zero factor property and solve the resulting two linear equations. First of all, let's do this. This is the given equation. We have to find the values of x that make this equal to 0. That's the object here. We have an ax squared plus bx plus c equals 0. Now we can factor this as x plus 1 times x minus 3. How do we know that? First times first gives me the x squared. The plus 1 times the minus 3 gives me the minus 3. The inner term is plus x, and the outer term is minus 3x. If we combine the inner and the outer, we get minus 2x. So first thing we do is factor right here. Secondly, we use the zero factor property on each part. So I set x plus 1 equal to 0, or I can set x minus 3 equal to 0, and when I set this equal to 0 and I transpose the plus 1 from the left to the right, I get minus 1, so that's one of the solutions. The other solution is x equal to 3. So now let's go and check. We'll check the answer with minus 1. We'll put minus 1 into x squared minus 2x minus 3. So we get minus 1 squared here, minus 2 times minus 1 here, and minus 3 here. I'm not separating here. The left side and the right side are not separated. So we get 1 plus 2 minus 3. Well, 1 plus 2 is 3. 3 minus 3 is 0. So the left side does equal the right side. That is with the solution minus 1. Now we put the solution x equal to 3 in, and put x equal to 3 back into this original equation here. So we get 3 squared minus 2 times 3 minus 3. 3 squared is 9. 2 times 3 here with a minus gives us minus 6 and minus 3. So 9 minus 6 minus 3 becomes 0. So the solutions are minus 1 and 3. Now if you go back to the previous page where we said the solution was minus 1, let's see how that might transpire. We factor this first of all. And since there's only one term, these terms are identical, I set x plus 1 equal to 0. And then x equals minus 1 if I transpose this from the left to the right. So the solution is x minus 1. And so if you go back and you check this, you can check it on the previous page where we did it right here. Excuse me. I did it right here. So here's the solution here. I checked the left side with minus 1. And minus 1 squared plus 2 times minus 1 plus 1. If you sum those three terms, it's 0. And the right side is 0. So that gives you an idea. Let's go over this again. We are given this problem, and we're asked to find the values of x that would make this equation true. First, we factor right here. And if the product of these equals 0, then either this term is 0 or that term is 0, and that's what we've done here. When we set x plus 1 equal to 0, x is minus 1. When we set x minus 3 equal to 0, x is 3. So those are the two solutions. If we put either one in, either minus 1 or 3 into the original equation, they both work. And then we went back and just showed for a case where there would be only one solution when it's a perfect square, because this term is the same as that term, so we just need to write x plus 1 equals 0. So that completes the basic introduction to solving quadratic equations.